students, today we will be discussing about refraction, refraction of light. And this refraction of light is very interesting. You will see certain examples and activities in this video. So let's jump into the examples and activity of refraction of light. This is IGCSE Physics, and welcome to Rentut. Now let us take an activity. An activity you will see the one denotes the first task. The first task is to take a piece of paper, mark an arrow towards the left hand side and just put it against the wall. Now the paper is put against the wall and you see a glass, empty glass is kept right in front of the arrow, and now the arrow you have to see from the front side. Once you see from the front side, there is no difference. It looks the same as if you had drawn on the paper itself. Now do one thing. You see on the third task, you pour a water. You pour in the glass water, and the fourth task you see the water is filling. Once the water is filling, you see the arrow is turning to the opposite side. It is not to the LHS. You can see the first arrow. On the fifth task you see the arrow is now pointing to the right hand side, whereas it was earlier pointing to the left hand side. Okay. Now what you do in the sixth task, again you fill it, you pour more water. In the seventh task you see again the second arrow is also changing. It is shifting from the left hand side to the right hand side. You see the eighth task, both the arrows are pointing towards the right hand side, whereas in the first task when you took this piece of paper, it was showing to the left hand side. So why this happens? Any idea? Just think why this happens. We will be discussing why this happens, why the light which was falling on the glass, empty glass, and when water is poured, suddenly the direction of the arrow is changed. Okay, so before understanding that concept, you need to understand what is rectilinear propagation of light. Rectilinear propagation in simple terms is ray of light. The rays of light, they travel in a straight line. You see the task 1 wherein the image is seen, there is an arrow pointing to the upward direction, and this image falls on our eyes, human eyes, whereas the light travels in a straight line. You can see straight lines are drawn, 3 straight lines are drawn. That represents that light travels in a straight line. So that is the reason why when you see the task 2, when you put an empty glass of water, empty glass, it shows the arrow in the same direction, left hand side. Okay, it is in the left hand side. So the third task, you have to take 3 or 4 cardboards and you have to put 4 holes, one on each cardboard. The point should be the size of a pinhole. And now see from the opposite side. On the opposite side you have ignited a candle, and you can see the candle's beam, small beam of light coming towards your eyes once you see on the opposite side. So this proves that light travels through these small holes. Okay, if these holes are aligned in one direction, only you can be able to see the candle light on the opposite side. If the cardboard or the pinhole is not properly aligned in a straight line, you won't be able to see. So that means this experiment has proved that light travels in a straight line. So this you have to keep in mind, light travels in a straight line. Now we will be coming back to the activity. You see the first task wherein the arrow has been changed, it has been shifted from the right hand side, from the left hand side to the right hand side. Okay, why this happens? You can see the image of the arrow was pointing towards the left. Once you put water of glass, it behaves as if certain convex lens is put inside. You see circles, the circles are pointing out that the rays of light is refracting, it is bending. Okay, it is bending towards the normal. We had seen in our previous video why it bends towards the normal, because the ray of light is passing through a medium. Now the medium, the arrow is drawn, the image is drawn is air, it passes through, the image of the ray of light passes through water. First circle you can see it is refracted, then it comes to the second circle where again it is refracted. So it is refracted twice, you can see. Now on the top also refraction happens twice, on the bottom also refraction happens twice. You can see the bottom of the water also, the image is getting inverted. So that is why you are getting in your retina, once your eyes captures the beam of light and it processes in the brain, in spite of the arrow being in the one direction, you will see in the opposite direction. Okay, so at the task 2 you have seen the arrow, the beam of light from the arrow passing through air, which is a rarer medium, and coming to water, which is a denser medium, and then it is refracting twice and coming out of the water. Okay, when it is coming out of water, again it is getting refracted and the image is inverting, it is getting inverted. So for that reason, when your eyes sees the refracted ray coming from the water, it sees in the opposite direction. The image is real and inverted. Okay, you see there is a focal point also drawn over there. Focal point, in a sense, the image comes to the focal point and it gets inverted. Okay, so the rays of light, you have to remember two things in this experiment. Rays of light in air, it is behaving as if there is no refraction taking place, and you see rays of light in water, once it comes in water, it behaves in an opposite way. Okay, so these two things you need to you need to understand it properly. Okay, in air it is in a less dense medium, and in water, when the image comes, it is in a denser medium, and rays of light in air, which is less dense, does not refract, and when the rays of light comes in the denser medium, it refracts. Now we will be taking another example. Here, in this case we have taken a pencil. You can see the task 1. In the task 1 you see the pencil is kept in an empty glass of water. In the task 1 we are pouring the water. Second also we are keeping on pouring the water. Once you pour the water and stop, you see on the third task, you see there is certain kind of, the image is getting bent. Light bends at the boundary of two mediums. Okay, so the media. So one medium is water, second medium is air. So on the boundary of these two mediums, refraction takes place. Okay, so light is getting refracted and bent when it passes from one medium to another medium. So when light passes from the less dense medium, that is air, to a much more denser medium, it bends towards the normal. Now when the light enters at an angle, it bends away from the original path. In this case, you can see if the angle of incidence is suppose 30 degrees. We are just taking a rough example. Suppose it is 30 degrees. Then the angle of refraction, you can see the angle of refraction, it is always less than the angle of incidence. So we will be assuming it, suppose it is 20 degrees, just for a simplicity sake, so that we can understand. So it is bending towards the normal, it is coming towards the normal. It should, the angle of incidence and angle of refraction, if it was 30, then it would be a straight line, but it is not a straight line. You can see it is bending towards the normal. That is why angle of incidence is more and angle of refraction is less. Now we will take a third example. Here we have taken a third example wherein we will be studying how rainbow forms. Okay, so here you can see the rainbow is getting formed. This is primarily due to sunlight. The sunlight comes and hit the water droplets. The water droplets is there. It hits the water droplets, and there is the light. The sunlight is getting split into seven colors: violet, indigo, blue, green, yellow, orange and red. So now what we need to do is that we have to take a hose in a sense. When we use we spray for garden, we use a hose or pipe. When in a beam of light, you have to just spray from the hose droplets of water. Once you spray droplets of water from a hose, you can see in the diagram it forms the color of the rainbow. Okay, so the image over there is showing rainbow. You can see rainbow is formed. How it forms, we will be explaining it once again. The water droplets, okay, the water droplets, the sunlight is hitting. You can see first time when it is hitting, the refraction is taking place. Then the refracted ray goes and hits the inner wall of the water droplets, and from there reflection takes place, and after reflection it travels straight and hits the inner boundary of the water droplets, and again refraction takes place. So here there is two refraction taking place in the spherical surface. You can see on the left hand side there is one more diagram drawn for simplicity's sake. The yellow color beam is the collection of these 7 colors coming, okay, hitting the water droplets. So you can see water droplet is circled as blue color. Okay, in that there is a small beam of light, red, in red it is shown. Okay, that is coming and hitting the inner wall of the water droplets and getting to another side, hitting the inner wall and getting refracted and going out. Okay, that is suppose 40 degrees. Then one more ray is coming, hitting the inner wall of the water droplets. It is shown in purple, and it is getting reflected, and it is going again, hitting the inner wall and getting refracted back. Suppose it is 40 degrees. Okay, 40 degree. So now what is happening is that you can see the picture which is shown at the bottom. Okay, it is showing how rainbows are formed. So from the cloud, water droplets, they come. It is suppose it is drizzling, and what the rain, it is not heavy rain downpour, just drizzling. Small water droplets are there in air, and this sunlight is falling on these water droplets. So once the sunlight hit the water droplets after refracting twice, it forms an image and comes and we can see that image in our eyes, falling in our eyes. These 7 colors we can see. So that is the reason why you see rainbow. Now this is a fourth example wherein sunlight passing through a prism. You can see this is the simplest example, but it is very difficult to see it in actually in practically in a lab. You need to do this experiment in a dark room. Okay, so this diagram you can see, once the 7 color light hits, a light is made of 7 colors, hits the prism. You can see there is a white prism, it is refracted, and 7 colors you can see it is formed: red, orange, yellow, green, blue, indigo and violet. Okay, so we have seen 4 examples now of refraction. First example, we took arrow on a piece of paper, put a glass filled water in, and we kept in front of that arrows, and you can see refraction taking place. The arrow was firstly pointing in the left hand side, has suddenly changed to right hand side after water is filled in that glass. Okay, secondly, we saw pencil is kept in a glass of water, and you can see the image is bent. Thirdly, we saw how rainbows are formed. Fourthly, we saw this example which is there right in front of you right now: the sunlight passing through a prism. It refracts and splits the light into 7 different colors. So this is what I wanted to convey. I have shown everything in picturistic format for you to understand it properly. Thank you for watching. You have a nice day.